A fast-moving object the size of Manhattan is hurtling towards our solar system.
3. I-Atlas interstellar object, larger than Manhattan, is racing through our solar system and will reach its closest point to the Sun on October 29, 2025.
And actually, it comes closest to the Sun on October 29th, when the Earth would be on the other side of the Sun. We won't be able to observe it.
Its size, speed, and strange orbit don't fit the profile of a normal comet. Astronomers are asking urgent questions, and Harvard scientist Avi Loeb is one of the leading voices pushing for answers. Let's explore the mystery of 3I Atlas and the disturbing possibility behind it. The disturbing discovery. Most of the space rocks we know, comets, asteroids, meteors, belong to our solar system. They circle the Sun, predictable as clockwork. But every once in a while, something breaks the pattern. That's what interstellar means. It didn't come from here at all. It came from somewhere else in the galaxy. And on July 1st, 2025, astronomers in Chile spotted exactly that. Using the Atlas Survey telescope, they saw a faint moving dot. Nothing special at first, but when they ran the numbers, they realized this thing was flying at nearly 135,000 miles per hour, far faster than any normal comet, and on a path that meant it would never loop back around. They named it 3I Atlas, the third interstellar object ever discovered. Its orbit was hyperbolic, which is science speak for it's not bound to the Sun. It'll pass through once and be gone forever. But what really got attention was its direction of approach. 3I Atlas wasn't drifting in from a quiet corner of the sky. It came from the constellation Sagittarius, which points toward the center of our galaxy. That area is packed with stars, dust, and radiation, one of the noisiest and hardest regions to monitor. Meaning this thing could have been barreling toward us for years, and we never noticed. By the time telescopes picked it up, 3I Atlas was already inside Jupiter's orbit. That's like spotting a car only after it's already halfway down your driveway. No time to prepare, no way to get ahead of it. And from the very beginning, this visitor didn't behave like any ordinary comet. It looked larger, brighter, and far stranger than expected, which immediately raised a chilling question. What exactly had just entered our solar system? Because once scientists mapped its orbit, the story got even more disturbing. A suspicious orbit. When astronomers charted the path of 3I Atlas, the first thing that stood out was its retrograde motion. That means it's moving against the normal direction of the planets. Most interstellar objects do that, so in itself, it wasn't shocking. But then came the detail that raised every eyebrow in the room. Its orbit was tilted by only 5 degrees off the solar system's plane. To put that in perspective, most interstellar visitors cut through the solar system at steep angles, like throwing a dart at a spinning record. But 3I Atlas isn't cutting across. It's gliding almost flat, along the same plane where Earth, Mars, Jupiter, and the rest of the planets orbit. That kind of shallow angle is extremely rare, almost too neat. Even stranger, its trajectory lines it up for near passes with Venus, Mars, and Jupiter, in that exact order. The odds of this happening naturally are tiny. Some researchers have run the numbers and say the chance is about 1 in 20,000. In other words, you'd have a better shot at being struck by lightning and winning the lottery on the same day. Then there's the timing. Its closest point to the Sun, called perihelion, happens in late October 2025. And guess what? During that exact period, the Sun will be between Earth and 3I Atlas, which means from our perspective, it will be completely hidden behind the Sun, out of view for every ground-based telescope on Earth. That blackout window just happens to coincide with the comet's most active phase, the moment when it's closest to the Sun and most likely to reveal what it really is. For scientists, this feels like the worst kind of cosmic luck. But for skeptics like Harvard astrophysicist Avi Loeb, it feels like more than a coincidence. If an object wanted to slip past observation, he argues, this is exactly how it would do it. Line up with planets, sneak behind the sun at the critical moment, and move on before we can get a clear look. Now, mainstream astronomers say it's just unusual orbital mechanics. No more, no less. But even they admit this orbit is one of the strangest on record. And when paired with the object's unusual size and brightness, it left many wondering, are we really just dealing with a comet here? Or something that was placed on this path deliberately? Because the orbit was only the beginning. When scientists measured its actual size, things got even more unsettling. A giant among visitors. If the orbit of 3I Atlas raised questions, its sheer size made jaws drop. When it was first discovered, astronomers thought it might be small, maybe less than half a mile across, similar to previous interstellar objects. But as more data rolled in, those early estimates had to be scrapped. New high-resolution imaging suggested a nucleus anywhere between 2.5 and 7 miles wide. That would make it the largest interstellar object ever recorded. To put that in perspective, Manhattan Island is only about 13 miles long and just over 2 miles wide. 3I Atlas could rival that footprint, a cosmic visitor the size of a major city. It's also about twice as large as the asteroid that wiped out the dinosaurs 66 million years ago. And unlike a near-Earth asteroid, which might circle back, this one is a one-shot deal, tearing through our system before disappearing forever. That scale is more than just a number. In astronomy, larger interstellar objects are extremely rare. Most models predict that small fragments, football field-sized or smaller, should be common. But an object several miles wide? That should only pass through our part of the galaxy about once every 10,000 years. Yet here we are, spotting one after less than a decade of modern surveys. Its brightness also doesn't quite match expectations. If 3I Atlas were a solid reflective rock, its glow would imply something even bigger, close to 12 miles across. That's a massive chunk of material to be flung from another star system, raising tough questions. How did it form? And what kind of violent event ejected it into space? For some scientists, the size alone suggests 3I Atlas could be a unique relic, a piece of galactic history untouched for billions of years. For others, it's the combination of rarity and timing that makes it unsettling. Seeing something this big, this soon, forces us to ask whether we've underestimated how common these objects are, or whether something else explains why it showed up now. Whatever the answer, its scale makes one thing clear. 3I Atlas is not just another comet. It's a heavyweight, a true outlier. And its behavior only got stranger when scientists noticed it was already active, long before it should have been. Activity where it shouldn't be. One of the most baffling discoveries about 3I Atlas came not from its orbit or size, but from its activity. Normally, comets start waking up as they get close to the sun. Heat causes ice to vaporize, releasing gas and dust that form a glowing coma and tail. But 3I Atlas wasn't following that script. When astronomers pointed powerful telescopes at it, including NASA's Infrared Telescope Facility and the Gemini South Observatory, they saw that it was already active at a staggering distance of 370 million miles from the Sun. That's well beyond the orbit of Mars, a place where most comets remain frozen and quiet. Yet here was an object visibly shedding material, long before the heat should have reached it. Even stranger, its tail wasn't pointing away from the sun, the way solar radiation normally pushes a comet's dust and gas. Instead, parts of its tail were angled toward the sun. This suggests the dust particles were much heavier than usual, resisting the sun's radiation pressure. That kind of behavior has no easy explanation. The coma itself also appeared unusual. While faint at first, it carried a distinct signature, large, dense particles mixed with gas that didn't match the neat, predictable flow of an ordinary comet. Astronomers called it a misbehaving coma, a sign that something very different was happening on or inside this object. For a while, the debate was whether 3I Atlas might be breaking apart, with internal stresses forcing material outward in odd directions. But the data didn't fully support that. The activity wasn't chaotic. It almost looked controlled, steady, persistent, and not driven solely by the sun's energy. If 3I Atlas truly is a comet, it's a highly unusual one, displaying behavior we don't often see even in rare long-period comets. If it's not, then scientists are left with more unsettling questions. Is this outgassing natural, or is it something else, something we don't yet understand? By this point, researchers knew they had to dig deeper. The orbit was strange, the size was unprecedented, and now the activity looked out of place. To understand what they were really looking at, scientists turned to the chemistry, and that's where things became even more extraordinary. A time capsule older than Earth. When scientists analyzed the light coming off 3I Atlas, they weren't just looking for brightness. They wanted to decode what this object was made of. Every material leaves a chemical fingerprint in the spectrum, and telescopes like Gemini South and NASA's Infrared Telescope facility provided exactly that. The results were astonishing. The object contained water ice, silicates, carbon-rich material, and organic molecules. On paper, those are familiar ingredients. Many comets in our solar system carry the same components. But what set 3I Atlas apart was its age and preservation. Analysis suggested the ice and organics had been locked inside the object for more than 7 billion years. That's older than Earth, older than the Sun. Essentially, 3I Atlas is a time capsule from the galaxy's ancient past, a relic formed before our solar system even existed. Tracing its origins, astronomers found the chemistry pointed to the Milky Way's thick disk, a region full of ancient stars and primordial debris. This isn't the bustling, star-forming part of the galaxy. It's an old neighborhood, where the raw ingredients of planets and life have been sitting untouched for billions of years. If this object truly came from there, then it has carried material across interstellar space for longer than life has existed on Earth. Even more intriguing was how unaltered the chemistry appeared. Most comets we study have been reshaped by countless trips around the sun, their surfaces baked and rebaked by heat. 3I Atlas hasn't. It's pristine, like a fossil dug out of untouched rock. That makes it an invaluable scientific target, a sample of material we could never recreate on Earth. But while its chemistry thrilled researchers, it also deepened the mystery. How could something so ancient, so untouched, suddenly spring to life so far from the sun? Why did its coma behave differently than expected if its core materials were typical cometary compounds? This contradiction, familiar chemistry but bizarre activity, left scientists split. On the surface, 3I Atlas could pass as a natural comet, but dig a little deeper and it doesn't quite add up. And that's where the debate took a sharp turn, as some scientists began to float a possibility most of their peers refused to even say out loud: Avi Loeb's disturbing hypothesis. For most astronomers, 3I Atlas is an exciting but natural object, but not everyone is convinced. Dr. Avi Loeb, a Harvard astrophysicist known for pushing the boundaries of cosmic debate, has suggested a far more controversial idea. What if this isn't just a comet, but something artificial? Loeb points to several unusual details. First, the precision of its orbit. Remember, this object passes close to Venus, Mars, and Jupiter in sequence, and times its perihelion when Earth can't observe it. Statistically, that's an incredible coincidence. According to Loeb's math, the chance of such alignment is about 1 in 20,000. To him, it looks less like a random rock and more like a carefully chosen route. Second, there's the glow detected in front of the object rather than behind it. Normally, comets reflect sunlight and release dust in a trail pushed away from the sun. But 3I Atlas showed light concentrated forward, almost like headlights. Some call it an imaging artifact, others a dust anomaly. But for Loeb, it's a potential clue that we're dealing with technology. He's also raised the possibility of non-gravitational accelerations, tiny shifts in its motion that can't be explained by gravity alone. Oumuamua, the first interstellar object, showed similar unexplained acceleration. If 3I Atlas displays even slight evidence of controlled movement, that would push it higher on what Loeb calls the Loeb scale. The scale is simple. 0 means clearly natural, like a standard asteroid or comet. 10 would mean clearly technological, a craft that maneuvers, emits heat beyond solar input, or even transmits signals. Right now, Loeb places 3I Atlas somewhere in the middle, not confirmed, but worth investigating. Of course, the mainstream scientific community has pushed back. Most researchers argue that the object's activity still fits within cometary behavior, even if unusual. They say extraordinary claims require extraordinary evidence, and so far the data isn't enough to label this an alien probe. But what unsettles many is that Loeb's hypothesis can't be fully dismissed either. The size, the orbit, the forward glow all raise questions that don't yet have neat answers. And with the object's most critical phase hidden behind the sun, there's no guarantee we'll get clarity anytime soon. For now, scientists are split. One side sees a rare but natural visitor. The other dares to consider something far more radical, that 3I Atlas could be a machine, not a rock. And if that sounds extreme, the pattern of interstellar objects we've seen so far makes the question harder to ignore, a cluster that defies logic. Until recently, the idea of spotting an interstellar object was considered nearly impossible. For centuries, astronomers assumed if one ever passed through, it would be so rare that no human generation would ever see it. Yet, here we are. In just 8 years, we've logged 3. First came Oumuamua in 2017, the mysterious cigar-shaped visitor that had no comet tail and an unexplained acceleration. Then, in 2019, Comet Borisov was a textbook example of a comet, but with chemistry unlike anything in our solar system. Now, only a few years later, 3I Atlas is larger, brighter, and more puzzling than both. 3 visitors in less than a decade is not what models predicted. The expectation was 1 per 1,000 of years, not 3 in quick succession. So, what explains this sudden cluster? The first possibility is the simplest: detection bias. Our technology has improved. Telescopes like Pan-STARRS, Atlas, and soon the Vera Rubin Observatory scan the skies constantly. Maybe interstellar objects have always passed by, and we just couldn't see them until now. But others argue this doesn't fully add up. The timing is too tight, the differences between objects too striking. Could it be that the galactic environment itself is shifting? Some scientists suggest we may be drifting into a denser region of the galaxy, one filled with more stray debris. Gravitational disruptions from nearby stars could also be funneling material into our path. And then there's the unsettling what if. What if these aren't random at all? What if some are meant to pass near us, or at least close enough to be noticed? Loeb and others ask the uncomfortable question, are we only detecting the ones that want to be detected? It's important to stress, there's no hard evidence for targeting, only suspicion born from statistics. Still, the fact remains. Going from 0 interstellar detections in all of human history to 3 in just 8 years is a leap that defies easy explanation. For astronomers, the cluster is both thrilling and alarming. It means we're entering a new era of discovery, where interstellar objects might become a regular feature of science. But it also forces us to rethink assumptions about how isolated or how visible we really are in the galaxy. And that's why what happens next with 3I Atlas is so critical, because its most important moment is about to arrive, just as it disappears from our view. The blind spot we can't escape. As unusual as 3I Atlas already seemed, what truly unsettled scientists was the timing of its closest approach to the Sun, its perihelion. For most comets, this is when things get exciting. Heat from the Sun turns ice into gas, activity skyrockets, and telescopes capture the most revealing data. But with 3I Atlas, the universe seems to have played a trick on us. Perihelion happens on October 29, 2025. That's when the object will be just about 130 million miles from the Sun, slightly closer than Earth's orbit. But here's the catch. From Earth's perspective, it will be positioned directly behind the Sun at that moment. For weeks on either side, every ground-based telescope will be completely blinded. The most important phase of this object's life in our solar system will play out in a cosmic blackout. To many scientists, this feels like frustrating bad luck. But skeptics like Avi Loeb see something more. If an interstellar object were maneuvering deliberately, this would be the perfect way to avoid detection. Flaring brightest while hidden behind the Sun, invisible to our eyes. Coincidence or not, the timing couldn't be worse for observation. All hope isn't lost, though. A few spacecraft currently on missions in the solar system may have the chance to catch a glimpse. ESA's JUICE mission, en route to Jupiter, and NASA's Psyche spacecraft traveling through the asteroid belt will both pass within about 30 to 40 million miles of 3I Atlas during perihelion. That's close enough for potential observation, if their teams prioritize it. Whether those instruments will be redirected in time remains uncertain. Adding to the urgency is the fact that, unlike Oumuamua or Borisov, 3I Atlas is large, bright, and unusually slow for an interstellar visitor. In other words, this may be our best shot in decades to gather detailed, real-time data on one of these objects. Losing that chance because of a solar blackout is a nightmare scenario for researchers. For the Galileo project and others scanning the skies, October isn't just a date on the calendar. It's the moment when 3I Atlas could either prove itself an exotic but natural comet or hint at something more unsettling. Some even speculate about the possibility of increased UAP activity after its closest approach, a connection projects like Galileo will be watching for. Either way, what happens during those hidden weeks will decide how we remember 3I Atlas, as just another rare rock or as the object that changed the way we think about visitors from deep space. And if the blackout wasn't enough, there's another problem. Humanity still has no real plan for what to do if one of these visitors turns out to be more than natural. When the universe has no plan B. For all the excitement around 3I Atlas, there's a sobering truth. If this object turned out to be something more than a comet, humanity isn't ready. We don't have a playbook, an organization, or even an agreed-upon strategy for how to respond. Harvard's Avi Loeb has been blunt about this. He's called for the creation of an international body dedicated to handling alien technology, much like how we prepare for asteroid threats or climate change. His argument is simple. While most scientists may dismiss the possibility of an artificial probe, the stakes are too high to ignore. If there's even a small chance we're dealing with technology rather than ice and rock, the world should be ready. Right now, though, our defenses and preparations are built for very different problems. We monitor asteroids and near-Earth objects, we model climate change, and we debate how to regulate artificial intelligence. But an interstellar craft? That isn't on the checklist. If 3I Atlas suddenly displayed controlled maneuvers or released smaller objects, we would have no official system for deciding what to do. Part of the issue is that any real response would have to be global. Space isn't divided by borders, and an object crossing the solar system doesn't care about national politics. But getting nations to agree on how to respond to something so unprecedented would be almost impossible. Do we treat it as a scientific opportunity, a military threat, or both? Who makes the call? Who takes the risk? Right now, the answer is nobody knows, and time isn't on our side. With observatories like the upcoming Vera Rubin telescope expected to detect new interstellar objects every few months, we're entering an era where these encounters won't be once-in-a-lifetime events. They'll be frequent, maybe routine. Some will be tiny fragments. Others could be massive, like 3I Atlas. If even one of them is artificial, the lack of preparation could prove disastrous. Loeb has even suggested a rating system, his so-called Loeb scale, to quickly assess how likely an object is to be natural or technological. A low score means it's clearly a comet or asteroid. A high score means we may be facing something that requires immediate international coordination. But right now, that's just a proposal, not a policy. The uncomfortable truth is this: if 3I Atlas, or the next object like it, turned out to be more than just rock and ice, we'd be improvising in real time. No plan or system, just scrambling to react. And that lack of preparation may say more about us than the object itself. Whether or not 3I Atlas is artificial, its very presence forces us to face a bigger question. What does it mean for humanity when the universe keeps sending these visitors our way? What 3I Atlas means for us? As 3I Atlas races through our solar system, it leaves us with more questions than answers. Even if every telescope agrees it's just a comet, the details don't quite line up. Its orbit is suspiciously precise. Its activity starts too far from the sun. Its materials are older than Earth itself. And its timing, slipping behind the sun during its most active phase, couldn't be worse for observation. But maybe that's the point. Maybe 3I Atlas is here as a reminder that the universe is far stranger than we've been willing to admit. For centuries, humanity believed the stars above were distant, untouchable. The idea that material from another system could cross into ours was almost unthinkable. Now, in less than a decade, we've seen 3 such visitors. That alone changes everything. Even if it's a natural comet, 3I Atlas is a time capsule. It carries water ice and organic molecules older than our sun, possibly formed in the Milky Way's thick disk billions of years ago. Studying it means looking directly at the raw material from which solar systems, and maybe even life itself, are made. In that sense, it connects us to the galaxy's deeper history. But if it's not natural, if even part of Loeb's controversial hypothesis is correct, then the implications are staggering. An artificial probe would mean we are not alone, and that other civilizations may already know about us. It would mean our story as a species has been unfolding under a much larger spotlight than we ever imagined. Either way, the message is clear. Our isolation is an illusion. We're part of a galaxy that is active, dynamic, and far from empty. Interstellar objects aren't rare flukes anymore. They're knocking on our door, one after another. Whether relics or reconnaissance, they prove that our solar system isn't a closed bubble. It's a crossroad in a much larger cosmic network. And here's the humbling part. 3I Atlas won't stay. In just a few months, it will vanish back into the dark, slipping beyond the reach of our instruments. We'll be left with data, images, and arguments, but not the certainty we crave. The essential question may remain unanswered. Was it a comet, or was it more? What's undeniable is this. 3I Atlas forces us to look at ourselves. Are we ready to face the reality of a crowded universe? Or will we keep pretending the sky is silent until the evidence is undeniable? Because the universe isn't waiting, it's sending visitors. And 3i Atlas may just be the beginning. The mystery of 3i Atlas isn't going away anytime soon. Stick around because we'll be here breaking it down as it unfolds. Hit like, share it, and subscribe so you don't miss what comes next.